Okay guys, today we are still on page 185. We're looking at 49 through 57. These are really easy problems if you'll just listen to me. If we have the log base 6 of 14, well, I could set it equal to x, and I could put 6 to x equals 14. I know the number would be between 1 and 2, but that's all I know. So there has to be another way. Well, there's a rule that says if you have log base b of x, then you can write that as log of x over the log of b. And notice when I didn't list a base, that's an understood base of 10. That is called a change of base formula. Change of base formula. We have 6 to the x equals 14, or we started off with the log base 6 of 14. Now guys, the way I remember it, and listen to me, I'm talking about font size. I'm not talking about the quantity of the number. You put the log of 14, to me the font size of 14 is larger, over the log of 6, and by the way, we're going to need a scientific calculator to work that out. So you will get your calculator, you will do the log of 14 divided by the log of 6 equals, and I got 1.47. And I told you we knew it'd have to be in between 1 and 2. And I could check it by saying 6 to the 1.47 power. And I'm going to do that. And I get 13.9. So see, that's not hard at all. Let's look at number 51. Log base 7 of 5. Which font is bigger? The 5. So it's simply the log of 5 over the log of 7. Work that out on your calculator. And I got 0.827. So that means 7 to the 0.827 power should be close to 5. Now I'm checking it as we speak. And I got 4.999. So that section's not hard. So after that, we can go on to the next section, and we are solving log equations on the next section. And I need you to turn to page 196. And we're looking at number 1. It says to solve the equation. Number 1, and it says 4 to the x plus 7 equals 8 to the x plus 3. Well, we have a problem. Our problem is because the bases are not the same. So I have to change them to the same base. And the base that I want to change it to is 2. Well, 4 is 2 squared. 8 is 2 cubed. And then we use our rules of exponents that say a power to a power we multiply. So it's 2 to the 2x plus 14 equals 2 to the 3x plus 9. If we have two things equal to each other and the bases are the same, then I can set the exponents equal to each other and solve for x. So I got x equals 5. We did problems like this last year. Number 3, I have 49 to the x plus 4 equals 7 to the 18 minus x. Well, again, we don't have the same base. We have to get the same base. So I'm going to change them to a base of 7. Well, 49 is 7 squared. And again, a power to a power we multiply. Then we set the powers equal to each other now because I have the same base. And I got x equals 10/3. Okay? Number 5 says 9/16 to the 3x minus 2 equals 3/4 to the 5x plus 4. For the third time, we don't have the same base. So I'm going to change it to a base of 3/4, and 3/4 squared is 9/16, I believe. And again, we use a rule that says a power to a power we multiply. So that will give me 6x minus 4. And if the bases are the same, then we can set the exponents equal to each other. And we get x equals 8. So far, so good. Let's look at numbers 11 through 20. Again, it says to solve it. If I look at number 11, remember ln is natural log. It's understood to have a base of e. So if I write that in exponential form, e to the 4th equals a. And I'm good with that. Let's see if I can do number 13 here. The natural log of negative c. Oh, sorry. Let's go to another page. The natural log of negative 2 is equal to c. Natural log has an understood base of e. So e to the c equals negative 2. Can we raise any number, e to any number, and get a negative number? Because if I put e squared, that's not going to be negative. E to the negative 2 is not going to be negative. So I can't raise e to any power and get a negative number. So therefore my answer is no solution. Okay, number 15. Pretend like this is any algebra equation. So we will subtract 14 and get 40. Still an algebra equation, divide by 2. Divide by 20 to get 2. Well, this is ln, understood to have a base of e. Write it in exponential form. Then to solve it for x, we'll divide by 7. So I'm good with x equals e squared over 7. And you could work that out on your calculator. Not too bad. 7,000 natural log of h equals negative 21,000. Again, it is an algebra equation. Divide both sides by 7,000. So the ln of h is equal to a negative 3. Remember, if it's natural log, it's understood to have a base of e. So e to the negative 3 is equal to h. Okay, number 19. 12,000 log base 2 of k equals 192,000. Well, divide both sides by 12,000 to get log base 2 of k equals 16. Write it in exponential form. And if you were to work this out, you'll get 65,536 equals k.